Hello everyone, welcome back to my channel Physics Lover. And आज से हम स्टैटिस्टिकल मैकेनिक्स उसमें इंसेंबल थ्योरी का डिस्कस करेंगे। इस लेक्चर में इंसेंबल क्या है, फेज स्पेस क्या है, व्हाट हैपेंस इन ensemble theory, what is the leading thermodynamical variables, and so on. And also here categorizes the ensemble in three types and उसका सिस्टम कैसे है, वॉल्स कैसे है, वो सब देखेंगे। चलो, ensemble थ्योरी ऑफ स्टैटिस्टिकल मैकेनिक्स क्या है, मैं देखता हूँ। Ensemble theory is just mathematical tools to study the statistical mechanics. It is just the mathematical tools which is used to study the statistical mechanics. In ensemble theory, we consider an ensemble. Ensemble means that is the collection of large number of mental copies of the original system. These mental copies mean like a photocopy of the original system that are macroscopically identical but different microscopically. Each system in ensemble is different microstate. In ensemble theory, we just consider an ensemble. I mean, a collection of large number of mental copies of original system that are macroscopically identical but different in microscopically. Each system is ensemble is different in microstate. देखते हैं। Uh, you all very eager to know that what is the mathematical or computational technique or way by which we can realize an above stop. Above stop means an ensemble that is the phase space. देखो, ये है mental copies. These are the mental copies. This is 1, 2, 3, 4, and so on. There are many mental copies of the ensemble. Each have microstate NEV. Each has a microstate NEV. And this is the our microstate. NEV is the microstate. There are three type of ensemble in star mechanics, or there are ways to study system in star mechanics in the three ways. These are the canonical ensemble, microcanonical ensemble, another is grand canonical ensemble. Generally, all these ensemble approaches entirely different, but final result are same. Why? This is the one questions. इसका आंसर हमें फ्यूचर में मिलेंगे. And next one is generally we prefer the canonical ensemble. Why? इसके भी हम पीछे डिस्कस करेंगे. And this is the phase space, that is a QP space. Phase space is a position QP space. Generally, phase space is a QP space. You know all what is the Q and P. P means a momentum, and the Q is the position. In the space is called the phase space, and phase space can be categorized into the two parts. Phase space further categorized into the two spaces. These are the mu space and another is a gamma space. This is the gamma space, this is the mu space, and further collection of mu spaces or sum of mu spaces is called the phase spaces. अब क्या है ये mu spaces? देखो, this is only for the single particle. Mu space is defined for the single particle, but the sum of single I means a collection of mu spaces. Here is n equal to 1 for a single particle. For n is greater than 1, n particles, this is called the gamma space. This is the mu space, this is the gamma space. And mu space is phase space of single particle. Let's check the dimension of mu spaces for the single momentum particles. And xyz is the positions, xyz is the positions in the 3D. In 3D, corresponding momentum are px, py, and pz. These are the corresponding conjugate momentum, not a momentum. We call the momenta. And these are the position. XYZ is a position, and the conjugate momenta is px, py, pz. In 3D, spatial degree of freedom f equal to 3. Let's check dimension of the phase space. Number of phase space is equal to the n cross dimension of mu spaces, where n is the number of particles. And degree of freedom in n dimensional space f equals to d into n minus k, where d is the dimension, n is the number of particles, and k is the number of constraint. And why we are studying the phase spaces? Look at here. It is the connection between the phase space and ensemble theory. Because of phase space connect the relationship between the phase space and ensemble theory. And we realize ensemble theory very easily. And question is arises how? Look at this. This is the position uh, along the x direction always, and momentum is along the p direction. There are some dotted line representing a lot of ensemble in this section, and this is our ensemble, and these point representing the phase point on the graph p versus q. At point in the phase space called the phase point or the representative point. These are called also representative point. In the next, this point is actually denote the one of mental copies of the system in ensemble. Exactly, this point actually denoted the photocopy of the system in the ensemble theory. These are our ensembles, and these points on the graphs, these point on the graph representing the phase point represent a system in ensemble. A collection of phase point is representing the ensemble. Phase evolves with the time. With this time evaluates the phase point is represented by the Hamilton equations. This is q dot, and this is the del s by del p, and another is a p dot, which is equal to minus, let me correct it, minus del s by del q, minus del s by del q. And the time evolution of the phase point is represented by the phase space trajectory in qp space, that is the phase space. In this section, h is the Hamiltonian of the system. Another graph is, this is the p versus q graph. Here each point, the graph is not intersect, is not touched with the another curve. So these are separately, these are intersect if s equal to st. Hamilton is a function of time. Won't intersect if h equals to st and v equals to the v. If the potential is depend on the position and the Hamilton is as a function of time, then these points do not intersect, won't intersect. And this is the very much important point in the phase point criteria. It happened when V is a function of Q, only not a function of time, only not as a function of time. And next one, in this case, if the Hamilton is not equals to the function of time, then the Hamilton is equal to the total energy of the system, and E will be conserved. Look at there. This is the point P, care position P and the momentum Q, and this is our ensemble. Points, each point crossing the graph separately and not intersect. Obviously, the mean or average of these trajectories will represent the behavior of original system. This is the reason that rely on the statistical mechanics instead of the thermodynamics. Why we replace the stat mechanics using stat mechanics instead of thermodynamics? This is the main reason. The mean or average of these trajectories will represent the behavior of original system. This is the reason that they rely on the statistical mechanics instead of the thermodynamic. Stat mechanics is more general than thermodynamics, that's why. And we have the comparison between the three type of ensemble. There are three type of ensemble: micro canonical, canonical, and grand canonical. Uh, these are the ensemble. Uh, with the macro study is the NAV, another is a NBT, another is a MUBT. There is a N and E and V, N, V and T. Only difference is E and T. But in case there is an another chemical potential is arise. The chemical potential is energy release in a chemical reaction. Let's see walls. Here n is a constant. This implies that impermeable or the impenetrable number of particles is confined over the microstate. Each mental copies have the microstate is NEV, so n is a constant. And next one is a V. This is the volume. Volume of the wall is also constant because it has a rigid wall. Mm, mm, because of V is a constant Y. If we press or compress or stress the wall and don't effect appear on this wall, there is no any effect. The wall is constant, so this is the rigid wall. Next one is a energy. There is no exchange of heat, that is the adiabatic walls. There is no exchange of energy, that is the adiabatic walls. And the system is a closed system. Next one, in case of the canonical system, NBT is a function of microstate and walls is n equal to constant. This implies that the impermeable or the impenetrable and volume also is a constant because of rigid wall, and the temperature is constant. Here is the temperature is a constant, and walls is thermal conducting walls. Next one is the number of particles are changing in the system with the chemical potential remains the constant. There is a chemical potential, so number of particles are changing in the system, then the chemical potential will remain the constant. And mu is the constant, that means the penetrable wall or impermeable walls. And the grand canonical, that means the mu Vt, and mu is the constant, V is the constant, is the rigid wall, T is constant, thermally conducting walls, and the system is open system. Example like a bucket. Open system means there are three type of system: isolated system, closed system, and the open system. in the isolated system, there is no exchange of numbers, and there is no exchange of energy. There is no exchange of energy. This is exchange sign. There is no exchange of energy. This is the no exchange of energy. There is a no exchange of energy. There is also no exchange of energy. In case of the closed system, there is, let me erase this. There is exchange of energy, but not exchange of number of molecule. ठीक है? There is a exchange of energy. There is a exchange of energy in the open system. There is exchange of both energy as well as there is exchange of both energy as well as the number of particles. Both are exchanging. And this much also today. Thank you for watching.